How much cover crop dry matter do you have? What is your termination date relative to your planting date? In other words, are you terminating early where you've got a fairly low amount of cover crop biomass? Or are you terminating later, perhaps even rolling it after it heads out, where you're going to have a fair bit of dry matter? What is the impact of cover crop on soil moisture? This has always been a question with cover crops, particularly for corn. Cover crops can dry a soil out. Cover crops can also, after they're terminated and you get subsequent rain, cause the soil to be wetter than you'd like for your planting equipment. When it comes to the nitrogen, what is your current method of nitrogen management in your corn crop? And if you do manage nitrogen in a certain way, will the cover crop have an impact on any of what we call the 4 R's: rate, timing, placement, or the source that you might choose? What I'm going to talk about today is the work we've done to look at what most people care about in corn production, which is the rate of nitrogen. Our current situation and our current recommendations are based on a lot of earlier work that was done at this station and also in Lexington by a group of guys that were basically real active when I started here as a younger faculty member in the 1980s. A lot of their work was done with either pure stands of winter cereals like wheat or rye, and they generally found in that work very little difference in what was the optimal nitrogen rate, both in the presence or absence of a cover crop. Now, this work was done no tillage, so there wasn't any tillage in the equation, and that's why AGR1 just recommends that the nitrogen rate be according to soil drainage, what was the previous crop, not cover crop, and tillage system that's used. There was some work done in Lexington and here at Princeton looking at pure stands of legumes, or at least nearly pure stands. A lot of that was done with vetches, but there was also some work done with clovers, particularly crimson clover. And generally, that work found that depending on the amount of biomass, which related to how much nitrogen you had fixed in that cover crop, the nitrogen rate for corn could be dropped back something around 10 to 50 pounds of nitrogen per acre. Let's say an average of about a 30-pound nitrogen credit. But it depended upon, again, the amount of biological nitrogen fixation that occurred. People who terminated early didn't see as much benefit as those who terminated the legume cover crop later. And it also was related to the C to N ratio of the material. When they did have a few mixtures or when they had weeds in the mix, they ended up with a little bit higher C to N ratio. When the carbon to nitrogen ratio gets as high as that straw you're sitting on there, you can bet you're not going to get a whole lot of nitrogen from early, well, either early or late termination. In fact, you might get the reverse. You might get net nitrogen immobilization. So the bottom line is the C to N ratio that you get with a legume cover crop is much reduced, and it causes an earlier and larger net nitrogen release. This is an example of some of that work where I've kind of pooled it together. So what we have is yield on this axis, and we have nitrogen fertilizer rate on this axis. And we have 3 systems. The upper line, which is these closed circles, was a pure stand of hairy vetch, was the cover crop preceding the corn. These other 2 systems, which actually are pretty close together, are a winter wheat system, that's the closed squares, and a closed triangles is just winter fallow, meaning nothing but the residues of the previous crop. Previous crop in this system was either full season soybeans or wheat double crop soybeans. You can see that our recommendations basically are based on the fact that there's very little difference between these 2, and that's what most producers, if they used a cover crop at all, it was going to be a winter cereal. You'll notice that when we did have a good stand of hairy vetch, we did change the shape of this response function to nitrogen. You definitely see a bigger yield benefit to having that nitrogen when there's little to no nitrogen applied. And you also see that we see a yield benefit even out here when in fact both of them have leveled off. And that was attributed to what we call a pure rotation effect, just purely breaking the cycle, not having a cereal in there, having a legume in there. So you get some additional just net bang for the buck from breaking the cycle, but it's not a nitrogen benefit. The nitrogen benefit is in this part of the curve, and the rotation effect is due to that part of the curve. Well, what about now? You can see yield levels in that thing range from about 70 up to about 150, 155 bushel an acre. Well, yield levels for corn have substantially increased, particularly in the good years. The way we manage corn has changed, both in terms of no-till planters and how we manage the crop subsequent to planting. Nitrogen management for corn has changed somewhat. We have some of the same tools available, but we don't have ammonium nitrate anymore. Cover crop mixtures, however, have become more popular than the straight cereal or straight legumes which were very few because legume seed was expensive in the 80s and early 90s, but these mixtures have become more common. And how we're going to manage that cover crop has changed. Rollers were never available in that early work, and there's quite a bit of differences between those who terminate early and those who terminate later. So in partnership with the Natural Resource Conservation Service, they provided a lot of dollars in support of this project. UK, myself, Dr. Coyne and some others are involved in this project, looked at a project to try to get at this question. We had 4 locations in 2015, and I'm going to report on those 4 locations this talk. We have 3 more back in these fields when they rotated back to corn this year, and I'll have more data in the final report. The grower, because these are all on farm, all 7 locations, chose the hybrid, chose the cover crop mix, did the weed control, and all the basic fertility. The sites are located from the central part of the state all the way through to the western part. The final site to the west is in Hickman County. The experimental design is pretty simple. We just have, is the cover crop absent or is it present? And then we have 6 rates of nitrogen, if you include 0 as a rate, ranging from 0 to 250 pounds of nitrogen per acre. And those increments are divided in 50-pound increments. Now, absence of cover crop doesn't mean absence of vegetation. Here's an example photo from one of our fields. This is a 2015 photo. This is where the cover crop was drilled, and this is the area where it wasn't. And you can see we've got some weeds, we've got some volunteer wheat. So it's not purely absent, but that's the reality. So that's one of the reasons this work is being done on grower fields, was because the reality is the differences aren't quite the extreme that you might otherwise expect. When we applied nitrogen, we typically side dressed it somewhere between V6 and V8. That's 6 collars, not 6 leaves, 6 collars or 8 collars. So you're looking at corn that's approaching right in here at 8, maybe even in here. We use Super U, which is a urea product that is co-prilled with both a urease and a nitrification inhibitor. Ammonium nitrate's become increasingly hard to get, so for us this is kind of the new gold standard because it's urea that comes ready to go with inhibitors for the most common loss mechanisms we have. It's not cheap, I won't lie to you about that. We went ahead and put this on at V6 to V8, as I said before. We measured then what did we have in terms of what was in the crop. Our index of that is leaf nitrogen at growth stage R1, which is early silking. We measured grain nitrogen at harvest so that we could then multiply that by grain yield to calculate the amount of nitrogen removal we were getting in the crop. And then of course we also determined grain yield. So this is the first real data I'm going to show you, and I want to give a little bit about how the setup is. You're going to have on this axis what we call our dependent variable. We're going to have in this case leaf nitrogen, but I'm also going to show one for nitrogen removal and one for yield. On this axis we have our nitrogen in the 50-pound increment rates from 0 up to 250. And what we did here to get rid of some of the noise was we averaged our responses across the locations in 2015, okay? We averaged across locations. The red dots correspond to the system with cover. The blue dots correspond to the response in the absence of cover, okay? The first thing to notice here is there's a little difference in behavior at this end, kind of a convergence in the middle in terms of leaf nitrogen, and then there's some divergence at the other end. At this end, it's pretty clear that in the presence of this cover crop that we were using, on average, there was less nitrogen available because that point lies below that one. However, with added nitrogen, they tended to converge, and there tended not to be a big difference in this index of nitrogen to the crop. But you'll notice it starts to level out in the presence of cover. We're not getting additional bang for the buck because, again, there's enough nitrogen made available there, but it tends to level out and level out a little earlier. This one keeps on creeping up in the no cover system. So there's kind of an early indication here that we're getting some tie-up of our soil nitrogen in the presence of the cover crop. We're not getting as much out of it as we would if we left it fallow. If we look at nitrogen removal, we have a much more dramatic set of differences in this data. Again, we see this down here where, in fact, in the presence of cover, we get less nitrogen removal, less nitrogen recovered by the crop, in fact, than we do in the absence of the cover. But notice that as we get deeper into the data in terms of nitrogen rate, the system that has cover pulls ahead and typically is giving us greater nitrogen recovery by the crop and greater nitrogen removal in the grain. Some nutrient cycling occurring here of nitrogen, but in general there's some conservation of nitrogen occurring such that more of it ended up in the crop and was taken out. And it tended to level off in the presence of cover, and this one just tended to keep on going up in the absence of a cover crop. Now, these cover crops in these particular fields were actually all mixtures. Two of them had cereal wheat, two of them had cereal rye. One in each of them, just by chance, was kind of a vetch-based system, and the other one was crimson clover and one was Austrian winter pea. Nobody had 3- or 4-way mixes. They were all by 2-species mixes, okay? And in some of them, the amount of the legume was actually kind of small. They get blown away sometimes by a cold winter. But nonetheless, on average, we see this benefit. This is the yield. The yield tends to parallel the nitrogen removal more than it parallels the leaf nitrogen data. So again, we see a suppression of yield. Notice our yield levels, again, are substantially better. 15 was a good year, but notice we have moved up yield-wise relative to where we were in the late 80s, early 90s data that I showed you earlier. So we're still getting a response in terms of we're getting a suppression of yield in the presence of cover where we have no nitrogen. Kind of equivalent here, but as we pull into these other nitrogen rates, then we see a benefit to the cover crop. Now, part of this may be that pure rotation effect. Remember, there's a legume in this mix, and we see a little bit of benefit. There's other data from USDA in Maryland and other places that shows this as well. So the cover crop does give us a little more bang for the buck. This was a very good year, but nonetheless, we still see a benefit. Notice also, again, typically leveling off. So 150 is pretty adequate in this system here, but you might want to push a little higher than that in the system in the absence of the cover crop. So I'm going to share with you a few conclusions that we have. The cover crop typically reduced soil nitrogen availability when no fertilizer nitrogen was applied, and this is demonstrated in all the data, but it starts even with leaf N at R1. We attribute this to the fact that as that cover crop was decomposing, it still tended to immobilize nitrogen. Even though there was some legume in the mix, it still tended to immobilize nitrogen. But if you put a little fertilizer with it, and the nitrogen cycling tended to cause some conservation that then helped the crop out later. The response to fertilizer nitrogen tended to level off at a little bit lower nitrogen rate in the presence of the cover crop. Right now, it's somewhere between 10, 20 pounds of nitrogen per acre. Not as high as we observed with pure legume stands back in the 90s, but again, certainly better than what we observed with pure cereal stands also in the 80s and 90s. So the benefit to the cover crop actually seemed to be there in the presence of applied nitrogen. In other words, just going with the cover crop, as has been advocated by some, and is what you've got in organic systems, about all you got to work with, is a real, it's a real interesting synergism. The yield benefit to the cover crop when nitrogen was added was when the nitrogen nutrition was adequate. And with that, I want to thank you very much for your attention, and thank you for coming today, by the way.